Okay, today we are going to be looking at solving simultaneous equations, and we're going to look at a specific method which is called elimination. So that's the only method we're going to focus on in this video. Then there is a second video which is called substitution, which is a different way of solving these. In class, we've looked at having to plot straight line graphs of the two equations and finding the solution that way, but this is a purely algebraic method. So we've got two simultaneous equations here. They are simultaneous equations because they've both got an x in them and they've both got a y in them. There are two unknowns here that we need to figure out the solution to. So I need a value for x and a value for y that works in both of these equations. So elimination means that I need to get rid of one of those variables. So I'm going to try and remove it. I'm going to start by numbering my equations. So this one we're going to call 1. And this one we're going to call 2, and showing our working here is really important as it can get very confusing. Now I can see that I have got one y and one other y in each of my equations, so this is a fairly straightforward example. If I do equation 1 subtract equation 2, and they're nicely lined up for me, let's have a look at what happens. So I'm going to do 3x take away 2x gives me 1x on its own. 1y take away another y gives me nothing. There's my equal sign. And 7 take away 6 gives me 1. So we have already found a solution for x in this equation. X equals 1. I'm going to write my solutions up here. X equals 1. That is one solution, but of course I need to find out what the value of y is. So I'm going to substitute x equals 1 into one of my original equations. So either equation 1 or equation 2. It doesn't really matter which one we try. I'm going to choose equation 1. So if I do that substitution, I've got 3 times my x, which is 1, add y equals 7, that's my equation. So 3 add y equals 7. So my y value must equal 4. So now I've got a solution for y equals 4. Nice and quickly, nice and easily. Let's just check that our answer is correct though by substituting those values into the second equation. So I'm going to substitute x equals 1 and y equals 4 into equation 2. And if I do that, I should find that 2 of my x's plus 1 of my y's is equal to 6. So let's complete that substitution now. Equation 2 is 2 times my x, which is 1, add y, which we've calculated is 4, should give me 6, while 2 times 1 is 2, add 4 is indeed 6. So for that equation, our solutions that we established from our other equation are correct. So x must equal 1 and y must equal 4. We know that we've got the correct solutions there by doing that simple check. Okay, this one was a fairly easy example because we only had one y in each one, so we didn't really have to manipulate very much of our equation at all. If we have a look at this one, now it's simultaneous again because I've got x's and I've got y's in both of them, so I've got those variables. But this time, oh, too far. This time I have got 3 x's in one equation, 2 x's in another. And I've got 4 y's in one equation and 1 y in the other. So it's not as simple as the last time. If I subtracted this now, I would still end up with 3 y's altogether, which I don't want. So we need to make some changes to one of these equations so that we can eliminate. So I'm going to number them again, randomly numbering them 1 and 2. I can have a look at this and see which one is going to be easier to make the variables have the same coefficients. If I needed to make 3x and 2x, if I needed to change them so the coefficient was the same, then the lowest common multiple would be 6 and I would have to change both of them. I would have to change both equations for that to happen. But if I look at my y's, I can make the coefficient of the second one 4 very easily by multiplying my second equation by 4. So let's have a go at doing that now. If I multiply this equation by 4, I will get 8x add 4y equals 40. So I've multiplied everything in that equation by 4. I'm going to number this one 3 because I've now got myself a third equation. So that's my third equation, which I achieved by taking my second equation and multiplying it by 4. I'm going to bring equation 1 down just to make it clearer for me. 3x add 4y equals 20. And now I can see that if I subtract these two equations, I can eliminate those y's. So we're going to do that now. We're going to do equation 3, subtract equation 1, will give me 5x, if I do my columns again, 5x, my 4y take away 4y gives me nothing, and 40 take away 20 equals 20. And then we're going to divide by 5 on both sides to solve that, so x must equal 4. First solution, x equals 4. Of course, I haven't solved the simultaneous equations yet because I don't know what y is. So if you can remember back to our last step on the previous slide, the last thing to do is to substitute our value of x equals 4 in this case, into one of our original equations. I'm going to substitute it into 1. So 3 times the value of x, which is 4, add 4y equals 20. Well, that's 12, add 4y equals 20, which means that 4y, if we subtract 12 from both sides, must equal 8. So my y must equal 2. So there's my solution for y. Y equals 2. Quite a long and complicated method involving altering one of our equations and multiplying it by 4, then doing our elimination, and then doing some substitution to get our solution of y as well. Let's check it now. If you can remember our check, we substitute into the second equation. So I'm going to get rid of all my working out now, just so I've got some space, and I'm going to do my check down here. So to check it, I want to substitute x equals 4 and y equals 2, they are my solutions, into one of my original equations. Now we've already used 1, so we know that 1 works, so I'm going to substitute into equation 2 and see if that works. So 2 times my value of x, which is 4, plus 1 times my value of y, which is 2, should equal 10. 2 times 4 is 8, add 2 does indeed equal 10. So that means that my solutions for x and for y are correct. Okay, so time for you to have a go at one on your own. Think about how you're going to eliminate. Do you need to change one of the equations by multiplying or dividing, or can you go straight into the elimination? And then make sure that you end up with a solution for x and a solution for y, and that you check your answers in your second equation. Pause the video now and have a go, and then when you press play, it will take you through the answers. Okay, hopefully you've had a go at that one and you've got a solution. So, equation 1, equation 2. Now in this one, I can see that my y's are quite easy to make sure that they have the same coefficient. So I'm going to do equation 2. I'm going to multiply it by 2, so I end up with 2 y's there. If I multiply equation 2 by 2, I'm going to get 8x plus 2y equals 22. And we'll call that one equation 3. So now to eliminate, I am going to do, if I have a look, okay, I've got equation 3 has got more x's, so equation 3 subtract equation 1. Again, bringing that down just to make it really clear to me. So, equation 3 subtract equation 1. 8x take away 5x is 3x. 2y take away 2y is nothing. 22 take away 16 is 6. So x must equal 2 if I divide by 3 on both sides. That's my first solution then, x equals 2. Substitute that into one of my equations. I'll substitute into equation 1. So 5 times my value of x, which is 2, 5 times the value of x, which was 2, plus 2y should equal 16. So 10 add 2y equals 16. That means 2y is equal to 6, so y must be equal to 3. So there's the second part of my solution, y is equal to 3. Check it by making sure it works in equation number 2. Remember, we used equation 1 here to work out our value of y, so when I check, I'm going to use the other equation. So my check by substituting y equals 3, x equals 2 into equation 2. 4 times the value of x, which was 2, plus 1 times the value of y, which was 3, should equal 11. Well, 4 times 2 is 8, add 3 is equal to 11. So my solutions are correct. Hopefully you managed to get x equals 2 and y equals 3 using a method like that. Okay, some different practices for you to do. If we go back to the first page, if you need to have a practice at these ones because you're not confident on just the elimination and substitution yet, then have a go back and have a look at page 5, section A. If you're happy with that one and you want to have a go at where we have to change one of the equations, so where we have to multiply them or divide them before we eliminate, then you are looking at section B instead on the same page. And there's lots of practices on that one. One last thing for us to look out for is when we have a negative. If there are negatives in there, then we have to be a little bit more careful when we do our elimination. Let's have a look. First things first, I can see I don't have the same coefficient of y or x, so I need to change one of them. I'm going to multiply equation 1 by 2. If I do that, I will get 4x add 2y equals 16. Nope, didn't multiply that by 2, equals 32. So now I've got the same coefficient, but one of them is negative and one of them is positive. If we were to do exactly what we did before, this is now called equation 3, if I did now equation 3 take away equation 2, let's see what happens. There's my equation 2. So let's do 3 take away 2. I'm going to get 4x take away 3x is x, fine. I'm then going to get positive 2 take away negative 2. Well, when we know that when we do 2 take away negative 2, we actually end up adding and end up with 4. So that would give us positive 4y. 32 take away 6 would give us 26. That hasn't helped us at all because I still can't solve this equation because I've got two different variables. So I need to be careful here and really make sure that I think about how to eliminate. I still want to get that same coefficient. I want it to be the same digit. However, I need to make sure that I subtract or add as appropriate. So, in this case, what I actually want to do, if I've got a positive 2 and a negative 2, what I'm actually going to do here is I'm going to do equation 3 add equation 2. Let's see what happens. 4x plus 3x gives me 7x. Positive 2 add negative 2. Let's jot that down up here. Positive 2 add negative 2. Well, that we know becomes a subtract. So now I've got positive 2 take away 2, which is 0. Excellent. So I've ended up with no y's in there. And I've got 7x is equal to 38. Don't know why I was finding that so hard. 7x is equal to 38. And that gives me my solution for this last part. I can then work out what my x is. I can substitute it into my equation and I can solve my equation nice and straightforward in the same straightforward way as we were doing with the last one. But that's just one to watch out for. So again, some of those feature in section B of that practice worksheet. And then if you're really ready for a challenge, then you can start to look at some of the harder ones from section C onwards. If you are really comfortable, then you might want to have a look at page 7 rather than page 5 and 6. And the top section on page 7 involves you having to rearrange the equations first before you start eliminating them. Okay. You can pause your video now and you can have a go at the questions on your worksheet.